Friends, welcome back once again in the video lecture series of Data Communication and Networking. According to the SBTE syllabus, its subject code is 1618502. Today I am going to take the first unit, that is Fundamental of Data Communication. In this unit I will take the second lecture as Channel Characteristics. Okay, fine. So this is my credentials. Okay. So before going deeper into the video, let's take what are the points that I am going to teach in this video. Okay, so first will be your basic concepts, right? Next, after basic concepts, I will emphasize on channel. Then I will discuss about different characteristics of channel. Then I will discuss about what are the challenges that a channel faces in the real scenario, that is known as your impairment. What are the different cause of impairment? And after that, the first impairment is known as attenuation. Next one is your distortion. And after that, I will teach you about noise. After noise, I will teach you about types of noise. And after taking all the above points, I will try to summarize my lecture by giving the summary of the video, and also I will provide you good references. So let's take the first topic, that is what are the basic concepts about this channel. So a channel is defined as a path between transmitter and receiver. It's well known because there should be a path between which the information can pass from transmitter to receiver, right? Okay. This path means channel may be physical or logical in nature, right? Physical means wired and logical means what? Wireless, right? So in the third point I have covered that point, that is it may be your wired or wireless. So what are the different scenario of wire or wireless? When we are talking about wires, that means it is in wired communication, right? And whenever we are talking about free space, then it is known as your wireless, right? Okay, fine. So next point is what? The path provides a passage for the information or data from transmitter to receiver with certain amount of loss of information or data. See, whenever we are sending the information, it sends in the form of signals. So it may so happen that some amount of information may lose due to the resistance in the channel, due to which the signal gets weaker and the amount of information may lose. So there are some certain techniques through which we can overcome these challenges, right? So what are the challenges? Okay. In some cases, information may not reproduce or information may not reach to the receiver at all. This is also a very big challenge, right? So signal can be routed from one type of network to another with completely different characteristics. That means different channels can be routed within the network with occupying different path according to their characteristics, means their bandwidth and frequency. Okay, let's talk about channel. So in channel, this is the digital source here. This is the digital source. It wants to pass some information through this channel, right? So digital source is having some information. That information is being transferred through channel encoder, and through channel encoder it should be modulated well. So what does this area is known as transmitter, means transmitter does all these activities, right? So after encoding only the modulation takes place. What is the modulation? Modulation means the information is superimposed with the carrier waves, and finally after modulation it gets travel or transmitted through some channel. Channel may have some impairment like distortion. Distortion is also a type of impairment. noise. I have already included in the last video. There may be fading also or interference. So all these things are known under your impairment. So after reaching to the receiver ends, first of all demodulation is being done. What is the demodulation? घोड़ा उस घुड़सवार को उतार देगा और घोड़ा वापस चला जाएगा, राइट? वो घुड़सवार फिर से कहां जाएगा? चैनल डिकोडर के पास. इट विल गो टू द चैनल डिकोडर एंड आफ्टर दैट फाइनली इट विल डिपॉजिट टू द डिजिटल सिंक. Right? Okay, fine. So what are the different characteristics of channel? First is your channel bandwidth, right? Some issues are there. First is your channel bandwidth. Next one is your propagation time. Next one is your transmission time. And finally, you are having channel capacity. So let's talk about channel bandwidth first. So what is a bandwidth? Bandwidth is defined as a size of range of frequency that can be transmitted through a channel. Means a bandwidth is nothing but we are having two bands. One is your maximum, means we are having two bands of lower frequency and higher frequency, and the difference between these two is known as your bandwidth, right? That means what is the range of the frequency is known as your bandwidth, right? It is the volume of the information per unit time that computer or person can transmit and can handle, right? Okay, fine. The measurement of bandwidth is in hertz. Normally it is in hertz, right? Next one is your bandwidth is expressed as data speed. Bandwidth means what? Whatever the data speed means, what is the rate of your transmission of a data through the channel is known as your bandwidth, right? And it is being calculated in terms of bits per second. Bandwidth also determines how the data is flowing fast within the transmission path. So next point is your channel capacity. As the name indicates, what is the capacity of a channel? So it is the amount of the information per unit time which is handled by either link or node. See, how much amount of information that can be handled by per unit given time is known as its channel capacity. The message transmitted may be either similar or different. So whatever the message is being transmitted through in the form of signal, they may have the same frequency or different, right? Okay, normally they are measured in terms of bits per second. What is the transmission time? The time which is required for a message to flow within the channel, right? It's not like that the time taken by the message from sender to receiver. No, whatever the time taken within the channel is known as your transmission time. Okay, the size of the message must be divided, which is in the form of bits, must be divided by data rate, which is calculated in the form of bits per second of the channel over transmission takes place, right? What is the size of message? That is number of bits divided by the data rate is known as the size of the message. Sometimes it is also known as packet length divided by channel capacity, right? So for transmission speed there are two types of expression. First is your message, which is in bits divided by data rate, and second one is your packet length divided by channel capacity. See, I have not taken so many mathematical expressions because according to you that is not means, in my opinion, that is not compulsory here. Whenever I will tell you about some numericals, at that time I will introduce all these things in numerical portion. Okay, what do you mean by propagation time? So what is a propagation time? The amount of time which is needed for information to propagate from source to destination. See, what is the propagation time? Transmission time is the subset of propagation time. Propagation time is the entire time taken from sender to receiver end. That means from source to destination. Okay. It is the distance which is divided by signal propagation speed. Right? What is the propagation time? The distance, whatever the distance between source and destination, if that will be divided by signal propagation speed, then it will be calculated as propagation time. Okay. Channel latency is depending on media characteristics. What is a latency? Latency means to search something, right? And these characteristics may be your signal propagation speed or transmission distance. Okay, now let's talk about impairment. What do you mean by impairment? Impairment means there is something wrong in the communication system. As we know, communication system can be able to transmit analog and digital signal, right? So transmission media never be ideal, right? It never be ideal. It may have some imperfection. So transmission media may have some imperfection. This imperfection cause to the signal not to transmit very well through that channel. Why? Because if the transmission medium or transmission channel is having some imperfection, then how the signal will be travel or transmit through that transmission medium very well. So signal is also being affected. In other words, it will be also not perfect. So this imperfection cause signal impairment or simply impairment, right? So signals which are transmitted at the beginning of the medium is not the same signal which is received by the receiver. So this means that there is a cause of impairment in the signal. Okay. So due to these types of impairment, it deteriorates the quality of analog and digital data. Means both of the data is being deteriorated if such type of activity, means such type of impairment exists. So what are the different cause of impairment, or sometimes it is also known as types of impairment? Both are almost same. So there are three causes. First is your attenuation, second one is distortion, third one is your noise. So let's take a quick review on all these type of transmission impairment, that is attenuation, then I will teach you about distortion, then I will teach you about noise and their types. So let's start about the first type of impairment, that is attenuation. What is attenuation? It means the loss of energy that is in the weaker section. See what happens. I will explain you this first point by line, point by point, right? Okay. So whenever the signal is transmitted through the medium, it generally loses energy. Why it loses energy? Because there exists some resistance in the medium. So due to this resistance, what is happening, that whatever the electrical signals that are being transmitted, they normally get warm, right? Warm means the electrical energy is converted into heat, right? The electrical energy converted into heat in the signal, and due to this heat there is a loss of signal. However, this type of loss can be amplified by using a device which is known as amplifier at a regular interval of time to compensate the loss, right? Okay. So whether signal is losing something or it is gaining, what is the parameter which measure all these activities? So that is known as your decibel, right? That is, in short, we are also telling as dB. Okay. So decibel is used to measure the relative strength of the two signals or a signals at two different points. That means what are the strength between two signals, that will be also calculated by decibel, or the signal which is transmitting, what are their characteristics at two different points, right? Okay, fine. If signal is attenuated, then dB is negative. Decibel shows the negative value if the signal will be attenuated. अदरवाइज इफ इट विल बी एम्पलीफाइड, दैट मीन्स अगर उसको अगर स्ट्रेंथ अगर मिल जाएगा तो डेसिबल आपका पॉजिटिव में आपको ये चीज शो करेगा, ठीक है. सो दिस इज द गुड एग्जांपल ऑफ योर अटेन्युएशन. ये आपका ओरिजिनल आपका सिग्नल है जो कि ट्रांसमिट होना चाहिए था, लेकिन ड्यू टू द रेजिस्टेंस इन द ट्रांसमिशन मीडिया ये जो आपका जो सिग्नल है वो अटेन्युएटेड हो गया. अटेन्युएटेड मीन्स क्या, आपका सिग्नल यहाँ पे आपका वीकर हो गया इस पॉइंट पे, लेकिन दोबारा जब अगर एम्पलीफाइड हुआ तो ये फिर से अपने ओरिजिनल पोजीशन को अटेन करने की भरसक प्रयास करेगा. सो हियर वी आर हैविंग द पॉइंट 1 where the original images original signal is there. At point 2, this is the transmission time, sorry, okay, this is the transmission time, ठीक है, transmission through which transmission through the transmission media signal is passing. And here after transmission what we have assumed observed that our signal is attenuated. So if it is attenuated, amplifier will amplify or it will strengthen the attenuated signal. So decibel is the good measurement equipment through which we can easily predict where the signal is losing and where the signal is gaining its strength. So second type of impairment is your distortion. What does distortion means? When the shape or form of the signal is changes, that is known as your distortion. Means original shape and form is deteriorated, it gets changed, is known as your distortion, right? Signal is made up of different frequency which is known as composite signal. See, only one signal cannot be transmitted through the transmission media. Some of the signals are combined together and they are going they are traveling or they are transmitting through the transmission media. So these signals, how they are differing, these signals are differing due to their different frequencies, and when they are combined, this is known as your composite signal. Okay, distortion occur in these composite signals, right? Each component of frequency has its own propagation speed traveling through a medium. See, अलग अलग सिग्नल्स के अलग अलग फ्रीक्वेंसीज होती हैं, और अगर अलग अलग फ्रीक्वेंसीज अगर हो रही हैं तो उनका प्रोपोगेशन स्पीड भी अलग अलग होगा, और इसी वजह से जो उनका जो रिसीविंग एंड पे जो पहुंचने का जो समय होगा वो अलग अलग इन लोगों का डिले होगा, राइट? ओके, फाइन. व्हाट इज द नेक्स्ट वन? It means that signals may have different phases at receiver as did at the source end. Yes, अगर उन लोगों का फ्रीक्वेंसी अलग है तो फ्रीक्वेंसी अलग होने का मतलब प्रोपोगेशन स्पीड अलग है. प्रोपोगेशन स्पीड होने का मतलब है कि वो लोग डिफरेंट पाथ के थ्रू डेस्टिनेशन पे पहुंचने की कोशिश करेंगे, राइट? और इस पहुंचने में सभी के डिले अलग अलग हो सकते हैं. जैसे सपोज किया जाए कि हाँ, आपको अगर दिल्ली अगर जाना है तो अकॉर्डिंग टू योर पॉकेट विल अलाउ, सम ऑफ यू मे टेक द रोड बाई कार, सम ऑफ यू मे टेक द ट्रेन, और सम ऑफ यू मे टेक द फ्लाइट टू रीच दिल्ली फ्रॉम हियर. सो अकॉर्डिंग टू देयर प्रोपोगेशन स्पीड, द डिले टाइम reaching at Delhi will be different. Okay, so some more points will be discussed with the help of this diagram. So this is the center end. At center end we are having composite signal. What is a composite signal? Composite signal is a combination of too many signals with having different frequencies, right? So they will be clubbed together, and at the receiver end again we are having these components and they will be filtered out one by one. But here what is going to be happen, we can see here you are having the original image like this, but here you are having some part of impairment. This part of impairment is known as distortion. Okay, last, let's talk about noise. What do you mean by noise? Noise is another type of impairment. Noise exists due to unwanted signal which is generally mixed with the original message or original signal. So noise can corrupt the signal in so many ways. There are so many ways to corrupt the signal. One of them is thermal noise. Next one is your intermodulation noise. Next one is your crosstalk, and next one is your impulse noise. I will try to explain all these things one by one. Okay, so here we are having noise. We are having two types of signals. One is your large SNR and second one is your small SNR. So large SNR, when it is going through the channel, so it may so happen that a noise occur, and due to the noise, the output of this after transmission will be signal plus noise. Means this was the original signal when it was transmitted through the channel, but due to the noise in the channel, the output will be taken out in this form. Means entire this thing will be changed, entire its geography will be changed, right? Okay, fine. Same thing will be happen in the small SNR also. If we are dealing with small SNR, still some noise can be clubbed with this signal at the end of the channel, and the output of the channel will be changed due to noise. So what are the types of noise? First is your thermal noise. What is thermal noise? This is due to the random motion of electrons in a conductor which creates extra signals, right? Okay, fine. Due to the random motion of electrons, generally it creates the extra signal. This is also known as your white noise, right? This is also known as your white noise. Next is your what? Intermodulation noise. What do you mean by intermodulation noise? It will be explained with one good example. Suppose I am having two signals, S1 and S2, and they will be generating the frequencies. Let's say let it be S1 and S2. So it may so happen that the frequency will be clubbed together and it will be added. Means S1 plus S2 will be combined, or there will be S1 minus S2. So in the both cases, what will happen? The source frequency will be altered, जो कि नहीं होना चाहिए, and which may interfere the signal of the same frequency which is sent by the sender, right? Okay. So these are some examples of intermodulation noise. Next one is your crosstalk. Let me explain you in this in Hindi. Suppose आप टेलीफोन पे किसी से बात कर रहे हैं और पीछे से कुछ और लोग बात कर रहे हैं, तो व्हाट यू विल फील, देयर विल बी हिंड्रेंस. मतलब आपको कुछ चीज ऐसा लग रहा होगा कि पीछे से कुछ शोर आ रहा है ना? उसी शोर को, दैट इज बेसिकली नॉइज इज, right? That is basically noise is. So here technically crosstalk is an effect a wire on another, right? Means एक चीज जो चीज हो रही है, प्रोपोगेट हो रही है, उसके ऊपर एक और अनवांटेड चीज आ जाए, then the original message definitely it will be your altered or it will be affected. So one wire acts as sending antenna and transmission media is acts as receiving antenna. So this is one thing. What is the example? The same example which I have already given, that in telephone system, suppose you are talking to someone and पीछे से कुछ अगर आवाज अगर आ रही है, then it is not looking nice. Okay. Next one is your impulsive noise. What do you mean by impulsive noise? Impulsive noise or impulse noise is irregular noise which is generated by phenomena like power lines, lightning, spark due to loose contact of the electric circuit. See, if the electrical circuit or electric circuit is not fixed well, so it may so happen that there will be a problem in lines, lightning हो सकती है, there may be spark, and due to all these, whatever the noise will produce, it will be your impulsive noise. Okay. So primary source of this thing is known as your bit errors, right? It is also known as your bit error. And in data communication, इसी को हम लोग we are calling it as burst error. Okay. So let's talk about summary. So whatever we have covered in this video, the first one is your channel may be a path between transmitter and receiver. Okay, this may be your logical and physical. That is, your logical means wireless and physical means wired, that I have already covered in the third point. Okay, so what are the good issues in channel characteristics? They are channel bandwidth, propagation time, transmission time, and channel capacity. In data communication, signal can transmit either in analog form or in the digital form. Transmission media is not at all ideal. Very important. There may have so many imperfection in transmission medium. So, due to the imperfection in transmission medium, signal gets imperfect, which causes impairment. The first impairment is your attenuation, which loses its signal, and the signal, whatever the signal is losing, it is due to the loss of energy, right? There are some random or unwanted signal which are mixed with the original signal, is also known as your noise. Noise may be of so many ways, just like thermal wave, thermal noise, crosstalk, and all that. And here is some references. In references, I have covered some books, right? These are some good books. If you want to go for good content, you can go through this URL, which is I am already given it to you. And if you want to watch some video, so for video also, some good video for this video for this topic is already given on YouTube. So you may see those videos. So thank you so much for watching this video. This is the end of the slide number 2, or the video number 2. Thank you so much. Have a nice day.